you're entering here. Okay? Comma's right above your 1.
On the calculator, you just plug it in, right?
Which one did you get? Did you get this one?
Yeah.
Okay, well then you just plug it in. But some people get this as their result, and so they have to program it a different way.
There's not just
It depends on the calculator, yeah. You can have the same version of the calculator and have 2 different outputs. Not, well, the same answer, but it'll have a different interface. So I teach both ways.
What if you have like a 3x squared?
Well, then that goes in the parentheses.
What about when you do the dx? Is it just respect to dx?
It's with respect to x. It's saying, what are you integrating with respect to? Yeah. Okay? So let's try another one, shall we? I know you guys are excited about these because you can check your answers now. Yeah. Emily's like, yeah. You excited, Emily?
Yeah.
Yeah. All right, so let's do another one.
You always want us to draw that graph.
No, you don't always have to draw the chart, but sometimes it can be helpful to see it. Wes, was it worth sticking around for?
Oh,
Yeah, I thought so. Because you learned a new trick today. Yeah, I like tricks. Where the hell are my notes? Probably look at those once in a while, make sure I'm doing it right. What? Only works for definite integrals. Yep, because with the indefinite integral, what it is technically an antiderivative. So you took the derivative and then you took the antiderivative to end up back where you started. But now we're starting with some function and we're finding the area under the curve. So it's a kind of a different process. Yeah. Okay, so let's try this one. X squared plus 3 times 2x. And we're going from 3 to 5. Nothing's changed, you guys. If you needed more practice with your integrals, this is your section. Okay? You still have to decide which integral it is, find u, create u prime, you have, you want, make it look like the template, and perform your integral. Nothing's changed. Groovy? Except the very end. Now you don't have to find k, you just plug in some numbers and get an answer. It's a beautiful thing. So which integral is this? 1, 2, 3, or 4? This. 2. So what's my u? You guys are so timid. What's u prime? What do we have? What do we want? What's my integral? Yeah, not bad, right guys? Same thing we've been always doing, except now, instead of being done at this point, we're just plugging in numbers. So which one do I shove in first? Heard it. 5. Okay. So 5 squared plus 3 cubed over 3 minus 3 squared plus 3 cubed over 3. Boy, that's a lot of 3's. Equals. I like to do as much in my head as possible because throwing this into my calculator is a knucking nightmare. But throwing this into my calculator, 5 squared is 25 plus 3 is 28. This is manageable. 3 squared is 9 plus 3 is 12. You guys see how that is much more manageable in your calculator? Okay. Because at this point, you wouldn't even need to do it in your calculator. You can just do the function int, f and int. So what do you got? Is anybody out there tempted to cancel those 3's? Don't do it. Don't do it. Don't do it. Division and exponents. How much?
576.
576. Anybody else get that number? Whoa.
I got 40. I got 38.
Wow.
What the hell, you guys? Ryder? Yes, what is going on? It's 6741.33. Good Lord, try that one more time, chickens.
I think that he was doing one of them instead of.
They were just doing one of them? Well, that doesn't help. This is just a few keystrokes. You guys can shove that into your calculator, right? Yeah. Keep it up, Jesus. Yeah. You guys have it now? Anybody finally get the right answer? Yeah, anybody? Yeah, anybody agree with Ryder? Anybody? Awesome, awesome, fabulous. All right, I've got enough out there. Ready to try another? No? I heard that.
I feel bad.
Can we do it on the calculator?
Yeah, absolutely. Okay, so I'll just keep this in here. So what goes in this little box, guys? Everything you're integrating. So for you guys, those of you that get this, what goes in this box is x squared plus 3 quantity squared times 2x. Just like you see it. That's what you're integrating, right? And you're going from 3 to 5 with respect to x. So for you guys, this is what you would plug in. X squared plus 3 squared 2x. This effectively brackets your function, comma, x, comma, 3, comma, 5, close your parentheses. What do you get? He's so pretty. You like him, Emily?
Wait,
Yeah.
so why did you make us integrate on that side, but over here you just plug it in?
Because the calculator's doing it for you.
Oh.
You're perfectly capable of checking your own work now,
Oh,
which is beautiful, right?
yeah.
Because it's good practice to be able to shove it into the calculator and get an answer.
That's
But
the
it's
shortcut.
better practice to do it out loud, which is why, well, not out loud, but on paper. I want to see all the work, guys. I know your answers are going to be right because you can integrate now with your calculator. I want to see your work. If you don't show me your work, I'm going to mark it wrong. Devarius and then Helena.
I have a question on the, I'm kind of drawing a blank on the, what do we have, what do we want?
Aha. Okay, so you have your tattoo in front of you?
I do.
Okay, so you've got the steps in front of you, right? So the first step is make it pretty, and then decide which integral it is, right? So we've decided it's integral number 2. Integral number 2 looks like this. U prime u to the n with respect to x. So where is u located in this green?
Second,
Yeah, it's tied to the exponent. So which one of these is going to be your u?
x squared plus 3.
That's right, it's the one that's tied to the exponent. So u is x squared plus 3, and then we take its derivative. What we have is the thing that belongs where u prime should be. What we want is always, always u prime, because our goal is to get this exactly so that we can integrate it. Okay, does that help? Awesome. Did you guys get the answer with the calculator? No? Who said no? Helena, I'm coming to you. Was that why your hand was up? You can go in and just change it. You go second entry. Isn't that nice? Yeah. It's not, it's the whole function under arranged in a, bear with me, I'll show you. K shows you how much to move the function up or down. Now we don't have to worry about that anymore. We're not looking for the function itself, we're looking for the area under it. Okay? It's a shifting way of looking at what we're doing with functions. So before we were looking for function, now we're looking for an area. Does that help? Okay, what's the power of this, guys? The power is if you integrate a marginal revenue function from some number to some number, you're finding the revenue between those two values. So instead of integrating and finding a revenue function, finding the constant, and then plugging some numbers in and finding out how much that made, you can just integrate a marginal revenue from some X production level to some X production level. So say you want to know the revenue of your first 1,000 units, you just integrate your marginal revenue from 0 to 1,000. That's what we're doing. Keenan, Griffin, does that help? A little bit? So we're just shifting what we're doing. We're skipping some stuff. It's a, you don't look like you're buying it. Hang in there, you'll see it. You will, I know you will. Okay, let's do another one. Okay. God, it's hot in here. I'm like soaked. Disgusting. Oh, here we go. Let's say I want you to integrate this area that's shaded under the curve. How would you set that up? We're integrating what function? With respect to what? From 0 to 2?
And it's 2.
Oh, so you could integrate these separately, but is it the same function all the way across? And technically, are we stopping integration anywhere along this line?
Yes.
No. So we could do the whole thing, right? 0 to 4. You could do 0 to 2 and 2 to 4. That's two different integrals, and what a pain in the ass. And you could just go the whole way. Does that help out?
When would you stop?
You stop when the shaded area stops. So I'm not going to ask you to integrate to 6 because the shaded area stops at 4. Does that make sense?
Yes.
So which integral is this? 1, 2, 3, or 4? 1. What's my integral? Yes? I know. Plug and chug, guys. So we have 4 squared over 2 minus, whoa, yeah, it's gonna be 0, but I wanna see it. Minus 2 times 4 minus 0 squared over 2 minus 2 times 0. So let's see, 16 over 2 is 8. 8 minus 8 is, minus 0 is 0 is your answer. What? How can you get a 0 area when it's clearly a non-zero area? How is that possible? Take a look at it. Wes, what do you think? They cancel each other out. So what's the lesson? If the area is under the x-axis, the area is going to be negative. If the area is above the x-axis, the area is going to be positive. And if those two areas equal each other, they're going to cancel each other out. Gesundheit. How do you guys feel? What's the hardest part? Anybody? Okay. Let's do another one. And then I'll give you guys, oh, I already gave you the handout, right? Did I? Yeah, I did. Okay. Here we go. Let's do one more. Because I want you guys to be able to do the whole shebang. And I might do a revenue function with you as well. Do, 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 do. Do, do. How about this one? I love drawing this one every semester because it looks like a dinosaur. And everyone laughs at my stupid dinosaur. So this is y equals x squared minus x cubed. And I'm asking you to find right here. My little dinosaur. Oh no. Isn't that little funny? You guys don't tease me about my dinosaur. It's a very happy dinosaur. I know, he's so cute. Shut up, it's horrible. How do I know where to start integrating and where to stop integrating? How do I know? It's a shaded area, but what's my x values? 0 and something, but how do we figure out the something? That's important. So you have two options. Graph it and find the spot, right? Because it's one of the zeros. You can calculate zeros. Or you can do it algebraically. How do you do it? These 2 points are where the function equals 0. Okay. So y equals x squared minus x cubed. We're going to set that equal to 0. Factor out what I can. X squared equals 0. X equals 0. 1 minus x equals 0. X equals 1. So what are my two values? 0 and what? Hey, he's a tiny dinosaur. He's ickle bitty. He only goes from 0 to 1. Emily, was that you? Yeah. He's ickle bitty.
It's just like a big span, you know? It's a big graph for one.
For 0 to 1.
Yeah.
Not to scale. So we're going from x equals 0 to x equals 1. Go get them, guys. What's my integral? Yeah, don't overthink it, guys. Low goes low, high goes high. So you know more than you know. You have all the tools. You just have to figure out how to unpack them out of your brain.
I just have one question.
I have an answer.
Oh, so
that?
you got x squared minus x cubed, right?
Mm-hmm.
And then when you integrate, are you integrating now?
Mm-hmm. I sure
X cubed, so you just added a 1 because there was a 1 on the 1.
Look at your tattoo.
Oh,
Look
so
at
you
integral
actually
number
did the,
1.
that's what you
I
did,
did
okay.
integral number 1.
So you added 1, that became a 3.
Mm-hmm.
And then the 3 at the bottom,
It's, remember when you integrate an integral number 1, it's x to
yes,
the n
oh,
plus
okay,
1 over n
okay.
plus 1.
It's coming.
So
I'm getting
those
it,
are my n
yeah.
plus 1s.
Thank you.
Okay?
So that's where you integrated in the middle.
Mm-hmm.
And now you have a new command.
Yep.
And so you're just plugging in the 1 and the 0. But you'll have a minus in between them.
I sure will.
Okay,
So
I
this
got
is
it.
f of b, that's this guy,
Yeah.
minus f of a, that's this guy.
Okay.
So what's 1/3 minus 1/4? 1/12. This little area here, this teeny tiny little area is worth 1/12. Questions?
We were plugging it in the calculator. I did the FN integer.
Uh-huh.
And then x squared plus 6
Did you say plus?
Oh, yeah. I should have fucked up. Yeah, that's
it'll be minus. So you can just hit second enter, and it should pull up your original, and you can go through and just change that number instead of having to retype everything. How do you guys feel? Yeah. Now, let's do this with a revenue problem. So, does anybody have a book? Are you serious, Russ? Thank you. Oh, I love you. So great. Brownie points to Russ. 13-2. Right.
No extra credit.
It's all right. It's better than you think. It's better than you think. Let's do total income. Okay. Let's do total income. And I'll show you guys just how powerful this is and how nice it is. Hi, Dino. That you don't have to calculate K anymore. It's so great. So, suppose that a vending machine service company models its income by assuming that money flows continuously into the machines, which always cracks me up, with an annual rate of flow given by f of t equals 120 e to the 0.01 t. So this is annual rate of flow. Okay, and this is in thousands of dollars. Okay. Find the total income from the machines over the first 3 years. That's all I need to think of this. Find the total income. Total income over the first 3 years. So what do you think, guys? How are we going to set this up? We're given an annual rate of flow. That's a derivative, isn't it? Rate of flow, that's a derivative. And we're asked to find total. That's the original. So how do we go from a derivative to the original? Yeah, we integrate. What am I integrating? Mm-hmm. 120 e to the 0.01 t with respect to t. Where am I going from and where am I going to? 0 to 3 over the first 3 years. So we're starting at 0 time and going out to 3 years. Okay? Everyone cool with that? Which integral is this? It's 3 because of the e. So what's my u? And what's my u prime? And what do we have? 120. And what do we want? So what are we going to multiply and divide by? 10 straight. Yars. Circle what you want. Kick out what you don't. This equals, let's see, it's 1,200, it's 12,000. 12,000, 0 to 3.01 e to the 0.01 t. With respect to t, I can erase this noise. So what's my integral, guys?
So the 1,200 stays, 12,000 stays, right?
12,000 goes along for the ride. It's a new constant coefficient. What does u prime e to the u become when we integrate? E to the u. And we're going from 0 to 3. Pug shop. So we get 12,000. E to the 0.01 times 3 minus 12,000 is entire. E to the 0.01 times 0. Does this whole thing go to 0, guys? No. 0.01 times 0 is 0. E to the 0 is 1. 12,000 times 1 is 12,000.
But it's still a minus.
So it's whatever this is minus 12,000. It doesn't go to 0. Never assume that just because the X or the T or the whatever is 0, that the term is going to go to 0. You must go through the motions. Okay? What's my answer? What was that?
4,198.
4198.3. But this is over the first 3 years and it's in thousands, so careful. Was that you, Riley? Careful, careful. It's in thousands. Gonna wanna move that decimal 3 times. So this is actually 4198300 or 4,198,000. Is that right? That's right. 12,000 E. No. That's the right answer. 365.45. I was like, that's a little high, but not much. Just by a factor of 10. 365.45. So move that decimal 3 times and you get $365,450 over the first 3 years.
So why do we have total flow instead of total income?
Well, that's what it is. It's total income. So annual rate of flow of money into the machine, that's an income,
I see.
right? So I know you guys are really close to being done, but try to get one of them done on your handout. I'm gonna put up the homework and walk around and help you guys. Right here. Yeah, those are the old cheat sheets. You're welcome to tear through them. So Ryder's got the pile, and here's your homework. Yes, and you're. I want you guys to think about this real hard. We have, after today, we have 4 more lectures. 4 more lectures of new material. Time flew, and you just made it through calculus.
Now we have 3 weeks until our third exam.
Uh-huh. There's review days, there's, yeah,
When is what day is the
it's on the
group?
syllabus.
Thursday, 21st? Thank you.
So does anybody need help with the